Hello, and welcome to Ag Week 2021. This year, in honor of our 10th anniversary, we are highlighting innovative advancements, ideas, and individuals that have contributed to agriculture over the past 10 years in a series of 5 interviews. While we wish that these speakers could be with us on campus celebrating all that Purdue has to offer, we are thankful for their contributions to this year's Ag Week. So, without further ado, here are our presidential dialogues.
Hi everybody, and welcome back to another episode of the Ag Week 2021 Presidential Dialogue. My name is Audrey Kruse, and I'm here with Nick Bowser, and we are both seniors on task force this year. Our guests today are Dr. Torbert Rocheford and Evan Rocheford. Dr. Torbert is a professor here in the agronomy department, and both him and Evan serve as co-founders of the Purdue-affiliated startup NutraMaize. Evan serves as the CEO, and NutraMaize develops biofortified non-GMO corn. First of all, thank you guys for both joining us today. And if you could introduce yourselves, what you do with NutraMaize, your positions, your roles, just kind of give us a brief overview.
No, thanks for having us and thanks for the introduction. So as you said, my name's Evan. I'm the CEO and co-founder. Started the business with Torbert, who's my father. So that's how we got sort of connected, right, as co-founders, father-son team. And so we've been working on NutraMaize for about five and a half years now, and it's been a really exciting journey. So I basically manage all of the commercial side of the business, and Torbert heads up the research and development.
Great. Well, thank you for that introduction. So to kind of kick questions off today, I'm kind of curious, what led you to development with orange corn and carotenoids, and if there's anything specifically that led you to that compound as opposed to other nutrients?
Well, so carrots have beta carotene. They're orange because they have beta carotene, and beta carotene is also vitamin A. And there's vitamin A deficiencies in Africa. And I've been involved with a program called Harvest Plus, which is breeding corn for vitamin A, because they eat a lot of corn in Africa. And so if you're going to add vitamin A to it, you're going to make it orange. So carotenoids are different colors. So that's why it's that color. And I've worked on that for Africa for a long time, upstream breeding and gene discovery. But then we decided we wanted to work in the US. But we don't have vitamin A deficiencies, but we have deficiencies in lutein and zeaxanthin, which accumulate in our macula. And if you have deficiencies, you're more likely to get age-related macular degeneration. So carotenoids are compounds that the human body has co-opted over time in evolution to do very important functions. So our bodies like carotenoids. So we just want to do more.
Alrighty, so consumer acceptance is a big thing that research tries to cater to today. How are you guys handling consumer preference and acceptance in your corn? And are you thinking that there's going to be a big shift to biofortified food products in the future?
Yeah, I mean, we're big believers in biofortification. I think that ultimately the goal is that, in 50 years from now, we're not calling it orange corn. We're just calling it corn, because all of the corn is orange, right? And we've made everything more nutritious. And so, anytime something's different, there can be some friction, right, with certain segments. One of the things about orange, though, is that it's novel, and people aren't. Looking at sub-Saharan Africa, there's in certain places there's taboos against eating yellow corn because it's been traditionally animals, or it's been provided as food aid, and it's been of a low quality in their perception. And so, whereas orange is totally novel, and so there's no baggage with it. And I think as well, there's, in general, people have an association of bright color with nutrition, right? If you look at the foods that we think of as being nutritious, fruits and vegetables, they're mostly brightly colored, and a lot of that is actually directly derived from carotenoids. And so a lot of what we're doing is we're taking a staple crop, which traditionally have been used to fill bellies, right, with calories efficiently, cost effectively, but haven't necessarily provided a lot of other nutritional value in terms of nourishing people's needs for vitamins or minerals.
Awesome. Well, kind of building on that, we've talked about a lot of the benefits of biofortified crops. So I'm wondering what steps that scientists or policymakers, other people involved in agriculture, what can we do to kind of help facilitate further adoption of biofortified crops?
Who is we?
People involved in agricultural policy, the scientists themselves, people who market the crops, basically everybody involved, in the entire supply chain process.
They all can start eating orange corn. That would be a good thing to do. But it has to function at different levels. In terms of there needs to be education about eating biofortified foods. So it has to start at a high level. I mean, at an early level. It's kind of a vague question. There's just lots of things. Evan, maybe you can comment on this.
Yeah. So I think that the question is like, what are our priorities as in terms of as a culture, civilization, policymakers? And one of the things that actually has been sort of in the discussion recently is kind of switching from thinking about food insecurity and thinking more about nutrition insecurity, right? So this very much aligns with what we're trying to do here in the United States and what our partners are trying to do globally through biofortification, which is that recognizing that full bellies are not enough, right? The Green Revolution was extremely successful at providing enough calories to people across the world. I mean, to a large degree, we have eliminated caloric deficiency. Most food insecurity is the result of problems in distribution, political unrest, economic inequality, lack of infrastructure. But we have the tools, we have the technology to solve those problems. And so I think that really the big challenge now is how do we make food more nutritious, right? How do we make staple crops like corn or wheat or beans or rice, how do we make them so that they are providing, real nourishment, right, to people globally? Because most people across the world get the majority of their calories from, one of the top 5 staple crops. And so there's a huge opportunity to really address nutrition and also health, because there's significant implications, negative implications when people don't get enough nutrients or the right nutrients. And there's a lot of positive impacts of getting enough of those nutrients.
So Dr. Rocheford, as the head of R&D for NutraMaize, I kind of want to direct this question towards you. A lot of our viewers or listeners might not know what biofortified means. Could you kind of describe the agricultural innovations that has led to biofortification and how you, as the researcher behind the company, get carotenoids into this corn?
Sure. So biofortified means that we're just using biology to fortify the crop. So it's biological fortification, as opposed to sometimes they'll add certain minerals or iodine to food, but we're having the plant make it. So we're taking advantage of the biology of the plant. It's natural. It's not genetic engineering what we do. It's not GMO. We're just taking natural variation. Now, we've studied that really hard, and we found the best alleles. And if you think of eye color, if you look at people, there's different eye colors and there's different intensity of eye colors. So if we were breeding for dark brown eyes, and let's say in an animal population, not humans, we would select and cross the ones that are darker and find some that are even darker. But we know the genes now, and there's some key genes that we've discovered that increase vitamin A, and we just select that allele. So it's like selecting an allele for a certain eye color. If you could do that in animals. So biofortification is it's a natural way, and it needs to be. You asked earlier, what can we do? Well, it just needs to be implemented into breeding programs. Right now, the Midwest, the big companies, they breed for yield. They're not going to breed for biofortification because they don't get an incentive to do so. So,
where did most of your germplasm come from that you've selected these alleles from? Because I assume you drive down the road here in rural Indiana and you're not seeing a whole lot of orange corn on the side of the road. So where did most of your genetics come behind to kind of start the selections that you have now?
Well, subtropical germplasm, I work with CIMMYT, which is the International Research Center for maize and wheat. And we get germplasm, and it's naturally more orange. And there are centers of diversity for orange color. And one is the Caribbean Basin and some of the islands in the Caribbean. And then also Uruguay, northern Argentina, southern Brazil. That's another center of diversity. For some reason, the Native American Indians selected for dark orange in these places. And so that's where some of it comes, but some of it's not adapted. Like if you took it and planted it out at the agronomy farm, it would grow 15 feet tall because it's used to being close to the equator, and it waits until September for our days to get shorter. So that's the big process that we have is the, don't mind me, I'm getting a text from my wife. I'll text her back later. So that's the big challenge is adapting the germplasm, and then, but the genetic discoveries that we've had, we're using to just pull the favorable alleles in the carotenoid pathway that come from the tropical germplasm and leave a lot of it behind.
Right. Yeah, because basically there's a lot of diversity, but a lot of it has not it's not been really adopted or adapted for commercial use, right? A lot of these are unimproved accessions or landrace varieties, and so they might have really interesting and unique traits, but they're not really suitable for commercial production on a large scale. So a lot of what we do is we mine genetic diversity and then integrate that with high performing varieties that are adapted to the Midwest growing conditions and industrial production systems.
All right. So kind of to shift back to food security a little bit before we wrap up today. So a lot of food pantries have issues providing clients with access to, healthy, fresh food, just due to the, affordability of more preserved foods. So I'm kind of wondering, do you think your product can, help contribute to a solution to this problem? And, if so, can you kind of describe ways that it could?
Yeah, I think that there is a lot of opportunity for orange corn to help address, nutrition security or nutritional security, and this is really in a lot of ways what the innovation was designed to do, right? In sub-Saharan Africa, a lot of people, the majority of their calories come from white corn, and it's maybe not culturally appropriate or agriculturally appropriate to be like, oh, you guys need to start just growing lots of carrots and eating those because they have beta carotene, right? And so there's a similar issue with food pantries because it's challenging for them to manage produce and move it and give people access to it because of the way that the systems are set up, and without it perishing or going to waste right before it can be used. And so and also there's the question of cost effectiveness, right? Non-perishables are a much safer bet in terms of you're trying to get food to people, right? If filling stomachs is the top priority, it's the most logical thing to do. And so I think that the beauty of a product like orange corn or other biofortified crops is that you're kind of merging some of the benefits of fresh produce that might not be practical for certain applications, and you're delivering those through a shelf-stable, cost-effective, hopefully culturally appropriate format, such as what we sell in the United States. We sell a line of milled products like grits, polenta, cornmeal, corn flour. Longer term, we hope to get in a lot of other processed sort of applications like cereals and snack foods. But people today can purchase orange corn and get, significantly more lutein and zeaxanthin, which is extremely important for maintaining eye health as we age. Most Americans are actually deficient. We should be getting 6 to 12 milligrams a day. Most of us are getting maybe 1 to 2.
Okay. Can I make one comment to Audrey?
Yeah, of course.
You said you drive down the road, you don't see much orange corn. But if it was the 1890s and you were riding your horse from the family farm to Purdue, what color do you think the corn was?
Probably multicolor. I assume they had just about everything.
Half of it was white, half of it was yellow. So in another 100 years, half will be yellow and half will be orange.
There we
That's
go.
my goal, make all the corn in the U.S. orange.
There you go. That's a good goal
There
to
you
have. You heard it here.
There you go. Cool. Yeah, and if anyone wants to learn more about our products or our story, they can visit our website, which is professortorberts.com. Our brand is Professor Torberts, which celebrates my father and co-founder's lifelong dedication to improving the world through science and agriculture.
And Evan, is there any place that we can get a hold of this product, whether online or in stores or in restaurants?
Yeah, Amazon is another great place to purchase it, and we are working on getting more retail outlets carrying it across the state. So keep an eye out for it.
There you go. Well, very good. Thank you guys again. We appreciate it. And thanks to our viewers and listeners for listening along and kind of going with this whole Zoom interview thing that we have today.
Thank you so much for tuning into our podcast today, and thank you to all of our sponsors for making Ag Week 2021 possible. Make sure to check out other episodes of our podcast posted throughout the week.